Hello, this is the third episode of the Shabda podcast. I'm Ciprian Begu, a student of Vedic philosophy, and I'm here with Ashish Dalela to ask him questions about the ideas in his books. Today's topic is the incompleteness of science. Hi Ashish.
Hello, Ciprian. I never thought we will get so far, but here we are into the third episode. So let's go ahead and talk.
Okay, let's start. In the last podcast, we talked about some of the issues in current science. I'd like to use this discussion to go deeper. Maybe we can start by summarizing the problem. Is there one problem or many individual problems? And what are they?
There is one important problem in all of science which turns up in many forms in each area of science. It's like a pattern. And there's a root cause of this problem which I will try to discuss today. Every theory of science has some axioms or assumptions. And these assumptions describe some facts correctly, but not all of the facts. The facts which are described by the theory can be collected to form a set. Things inside the set are explained by the theory, but things outside the set are not. To explain the things outside this set, we have to add some new assumptions to the theory. Now you can search for these assumptions, and let's suppose that you find those assumptions which explain the facts outside the set. Now you obtain two types of assumptions. One, those which explain things inside the set, and second, which explain things outside the set. You can say that to explain things both inside and outside the set, we can combine the assumptions that respectively explains things outside and inside the set. The problem is that the moment you combine these two types of assumptions, you create a self-contradiction. This contradiction means that the inside and the outside of the set have to be treated differently. There is some fundamental difference between inside and outside, and you cannot break that boundary and bring everything inside. There will always be something outside which contradicts the inside. So every theory has some facts which lie outside the current explanation, such that all theories remain incomplete. But if we try to make the theory more complete by adding more assumptions to explain the currently unexplained facts, then the theory becomes inconsistent. So we are stuck between a rock and a hard place. The rock is that science is incomplete, and the hard place is that if we try to make it complete by adding more assumptions, then the theory becomes inconsistent. The reason for this incompleteness is that nature is constructed from opposites or duality. Wherever there is hot, there must be cold. So there are axioms that work for hot, but we must postulate the opposite axioms to explain cold. We cannot mix these two types of assumptions or axioms because it leads to a contradiction. But as we talked about in the previous podcast, we can organize these assumptions in a hierarchy. For example, there is a head and tail of a coin, and there is the coin which has both opposites. So first we go from consistency within the head to contradiction between the head and the tail. Then we go from this contradiction to a new consistency that emerges from the notion of a coin. Science is unable to make this transition because it lacks hierarchy. So we just describe the head, and then when we find the tail, we end up in a contradiction. We have to recognize this contradiction as the outcome of duality, and then rise higher in the hierarchy to find a new type of consistency. So contradictions are a stepping stone to deeper truth. If we get stuck with contradictions, we don't progress in knowledge. So this is the pattern for all theories in modern science. And it was conclusively demonstrated by Godel in his incompleteness theorem. This theorem shows that any theory that deals with numbers must be either inconsistent or incomplete. The theory is incomplete if it remains with just the head. The theory becomes inconsistent when it has to deal with both head and tail. And mathematicians are averse to this inconsistency. So they never talk about the tail, they only talk about the head. Since we do not incorporate the tail, we don't go deeper from head and tail to the discussion of the coin. And since we don't go deeper, the knowledge remains incomplete. In a sense, we are unable to deal with duality of this world and then the unity from which this duality springs. We just remain on one side of the coin. Every modern theory of science uses mathematics, which relies on consistency of the axioms. So every theory of science is unable to deal with duality, and therefore the theory is incomplete. Because we are unable to deal with duality, we cannot progress into deeper levels of reality to find a new unity. Hegel came close to describing the world as thesis and antithesis, which combine to form a synthesis. And the synthesis then becomes a new thesis with its own antithesis. But in mathematics, we can only have the thesis. Adding an antithesis to mathematics creates a contradiction. And if we are unable to deal with this contradiction, we never progress into the synthesis. Therefore, every theory of science which relies on mathematics and consistency of logic becomes incomplete. This means that every theory talks about some head of the coin, and then another theory talks about the tail of the coin, and these two theories remain mutually contradictory. Each theory is by itself incomplete, and incompleteness means that there are true facts, such as the tail of the coin, which the theory which never be able to prove or disprove. Or if we try to explain the tail using the same assumptions as we were trying to explain the head, we will end up in a contradiction. If we try to make the theory more complete, then we require two types of assumptions for explaining the head and the tail, which makes the theory self-contradictory due to the conflict between the old and the new assumptions. So this is a pattern for all of science, because it's a pattern for mathematics. This idea is formally stated in Gödel's Incompleteness, but nobody has diagnosed the problem to its root in duality. This is because, since Greek times, rationalism operates on the notion that the world is consistent. So contradictions cannot exist inside the world. If we allow contradictions, we break logic itself. The incompleteness of science is due to logic, which says that all things must be consistent. The fact is that the world is not consistent. It has opposites like head and tail, which combine to create a coin. So we have to accept the contradiction, then rise deeper to obtain a new type of unity. This requires a new type of logic, which Hegel anticipated when he spoke about thesis, antithesis, and synthesis.
This sounds very troubling. It seems to imply that we can never know all the truths, because there are contradictory truths like the head and the tail of the same coin. If we remain consistent, then we must also be incomplete in knowledge. If all science is incomplete, then doesn't this mean we have a fundamental problem in our method of knowledge? Does it not mean that we as humans can never know everything?
Well, yes and no. The problem is not so much about if we can know everything. We certainly can know everything. However, the knowledge of everything requires a model of knowing which is outside current science. You can also say that the language we are employing to describe the nature is limited because it tries to employ consistency rather than contradictions. The language of modern science does not allow the existence of opposites, but ordinary language allows opposites. When we say that a coin has a head and tail, we are giving it opposite attributes. So the same thing has two opposite properties, and yet there is no contradiction because these opposites are part of a coin and the coin reconciles the head and tail. But unlike head and tail, which we can see by our senses, we can only know the coin by the mind. Therefore, we reconcile the contradiction by a deeper level idea. So it is possible to overcome the problem of Gödel's incompleteness by changing the language and the logic that is used to describe the world. The issue of incompleteness in science is a very deep problem, arising from the fact that the world is duality and we need to reconcile contradictions. Apart from duality, there is another problem of the three modes of nature, which are called Sattva, Rajas and Tamas. The mode of Sattva denotes concepts, the mode of Rajas denotes activities, and the mode of Tamas denotes objects. Accordingly, there are three modes in language too. The words of language can represent concepts, activities, or objects, and we have to not just interpret the word, but we have to interpret it according to the mode of nature being used. For example, we all know that the same words can be used both as nouns and verbs. English words such as answer, attack, and address can be used both as nouns and verbs. Similarly, words such as president or bachelor can be used to indicate the general concept or the particular individual. The difference between the use of a word as noun and verb is that difference between the modes of Sattva and Rajas. And the difference between using a word to represent a common concept or a common noun and a particular individual constitutes the confusion between the mode of Sattva and Tamas. In ordinary language, we don't just use words, we also take into account the part of speech, such as noun, verb, adjective, etc. These parts of speech are the modalities in which the word can be used. But in mathematics, these modalities are missing. So we can use the same number to denote a concept, an activity, or an object. And we have no way of knowing which mode we are operating in. Basically, mathematics doesn't have the figures of speech. When the same number is used as a different figure of speech, a contradiction is created, or it can be created. For example, you can say that barbers shave those who do not shave themselves. Here the word barber can be used to denote a particular barber or the universal class of people called barbers. These are two modes in language, but in mathematics we don't have these modes. So if we ask, does the barber shave himself? According to the concept mode or the mode of Sattva-Guna, the barber must shave himself. And according to the object mode or the mode of Tama-Guna, the barber must not shave himself. This creates a contradiction, but the reason is different. It's due to the three modes of nature rather than the duality, such as that between the head and tail of a coin. Duality is about the oppositions within a single mode. For example, the words question and answer can operate as opposites within the same mode, for example, nouns or verbs. Then there are three modes. So by the combination of three modes and the duality of oppositions, we create 6 different types of distinctions that we must make in mathematics. These distinctions are represented as the 6 directions of space in Vedic philosophy, namely left and right, before and after, up and down. The 3 modes of nature and the 3 dimensions of space. The 3 modes of nature are the 3 dimensions of space, and the oppositions are the 2 opposite sides on each dimension. So even to do logic and remain consistent, we have to use the idea of space. Now, if you are familiar with modern logic, it doesn't have the notion of a space. In fact, mathematicians claim that what is true logically is true in all places and times. But the fact is that due to duality and the 3 modes of nature, we cannot talk about this universal truth. We are now compelled to speak about the truth at a particular place and time. and the logic becomes contextual instead of universal. We have already seen how duality requires a hierarchy which comprises of a head, tail, and a coin. So the solution to the problem of duality requires three parts. And then when there are three modes of nature, both duality and three modes of nature require the notion of space integrated into the logic, which means that logic only speaks about local or contextual truth rather than the global or universal truth. If we try to obtain universal truth by removing duality and the three modes of nature as modern mathematics and logic do, then we end up in incompleteness and contradictions. So there is a general pattern in all of science, which is that all of science is either contradictory or incomplete. But this problem can be solved if we reconceive logic as dealing with local rather than universal truth. Once the contradictions of duality and the three modes of nature are solved, then science can be complete. But we have already done substantial revision to the modern ideas of logic and mathematics in the process of trying to overcome this incompleteness.
Okay, so you're saying that the problem of incompleteness in science cannot be solved without changing the nature of logic and mathematics. Specifically, you're saying that we need to add duality of words into mathematics and we have to add parts of speech to mathematics. When these things have been added, it will be just like ordinary language. Can you elaborate some more on how this language is related to hierarchical space and time?
We already saw one reason for hierarchy, which is that contradictions necessitate a third entity that reconciles the oppositions. And this third entity is higher than the previous two contradictory entities. There is another profound reason for this hierarchy which comes from the three modes of nature. Quite specifically, the modes of nature mix again and again to create a hierarchy. Take, for example, the sentence, "I like singing in the bathroom." In this sentence, singing in the bathroom is a noun phrase, i.e., something that acts as a noun in the sentence. The sentence has the same structure as "I like it," where it has been replaced by "singing in the bathroom." So at the top level, singing in the bathroom is a noun. But if you look inside this noun, then singing is a verb and bathroom is another noun. So this noun phrase is a combination of a noun and a verb, which means at the top level the whole thing is a noun, but inside the noun there is another noun and a verb. So this is what we mean by the modes mixing with each other. There is a hierarchy in which the top level thing can be a noun. Inside the thing there can be nouns and verbs. Inside the verbs there can be again nouns and adjectives, and so on. In English grammar, we use the terms noun phrase and verb phrase to distinguish single word nouns and verbs from multiple word nouns and verbs. But truly speaking, noun phrase and verb phrase is just a convenient method to represent nouns and verbs. If we had to use only three modes of nature, then verb phrases will be verbs and noun phrases will be nouns. The problem we have therefore is one of hierarchy, which produces infinite types from only three modes of nature. Our problem in mathematics is that we are unable to deal with types in addition to quantities. And the modes of nature combine infinite number of times to create infinite types. So truly speaking, the problem cannot be solved simply by adding three modes of nature to mathematics. Rather, we have to add a theory of how these modes construct a hierarchy through combination, thereby producing infinite modalities. This is very important because modern logic also has a division called Modal Logic, which tries to deal with this modality in a non-semantic sense. For example, you can have temporal logic, possibility logic, etc. This logic is non-semantic because it doesn't recognize that from three modes you can create infinite modes. So first of all, modal logic is dealing with a mode at a time rather than three modes at the same time. And secondly, it fixes the modes, which means that we cannot create new modes by combining other modes. So even though modal logic makes a beginning, the real problem is semantic hierarchy. You will recall that in an earlier conversation I described how the world originates as Shabda Brahman or alphabets. These alphabets combine to create words. But the words are then mixed up with modes of nature, such that the same word can be a noun, verb, adjective, adverb, etc. And these modes are constantly combining, so there is infinite variety of modalities created from these three modes. Therefore, if you ask how incomplete mathematics is, the answer is infinitely, because it is unable to deal with any mode and therefore with a hierarchy of modes which produce infinite modalities.
It is sometimes said that mathematics deals with the world in a context-free manner, but ordinary languages are contextual. You just gave one example of this contextuality where, depending on the context, the same word can be a noun or a verb. Is this the only type of contextuality?
That's a good point. Certainly, the use of parts of speech is not the only type of contextuality. In Vedic philosophy, there are three broad kinds of contextuality due to Sat, Chit, and Anand. The contextuality created by parts of speech falls into the category of Sat because it gives each word a different kind of role within a sentence. The contextuality here is that every sentence must have a subject and object, a noun and a verb. So words in a sentence must be assigned these roles or parts of speech. However, apart from the contextuality emerging from the parts of speech, there is contextuality between the words themselves. For example, hot is defined in opposition to cold, yellow is defined in distinction to cyan and magenta, bitter is defined by its difference from sweet and sour, and so on. This is the second type of contextuality. Then there is a third contextuality in terms of in the methods of dividing. For example, color could have been divided into cyan, magenta, and yellow, or into red, blue, and green. If I see some red object, should I say that it has a mixture of cyan, magenta, and yellow? Or should I say that it just has redness as defined in opposition to blue and green? How are we dividing the whole into the parts? What is the method? These methods are also creating contextuality because they are mutually defined. This means that if we use one method here, then we must use the other methods elsewhere. And the universe must not just have all the roles and all the types, but also all the methods by which we can divide and know. This idea has a nice counterpart in atomic theory where the system as a whole is defined by the wave function. But this wave function can be divided into infinite number of orthonormal bases. It is like saying that I can cut the pie into pieces in many ways. There are many different types of knives that slice the pie into square, triangle, rectangle, etc. The slices of the whole cannot be determined a priori in atomic theory. Rather, you have to first bring a knife. These knives are measuring instruments which are used to classify. Just like when you start studying a subject, the first thing you do is formulate some principles of classification. By this classification, you break down a complex subject into individual smaller topics, and then you find examples of these topics. Similarly, to know anything, we must first bring the tools of classification, and then when the types are created, then we do the instances of the type. If you're studying biology, then first you identify the methods by which we are going to divide the animal kingdom into different species. Once this method of division has been chosen, we opt in a particular set of species. And once the species have been defined, then each species is given a particular type of role within an ecosystem. It all begins in the method of classification, and these methods create non-overlapping realities. So each method is a contrast to another method. These methods of classification are our emotions. Just like if you are in a bad mood, then a well-intentioned person who is trying to correct you will be perceived as an enemy, and a bad-intentioned person who is trying to appease you will be perceived as a friend. To correctly perceive the world, we have to change our mood or emotion. And depending on the mood, you classify things differently. So these moods are also defined contextually in relation to others. For example, good mood is the absence of a bad mood, and bad mood is the absence of a good mood. Things are conspicuous by their absence, and we cannot create a pure good or bad mood because it is relational. To create correct perception, we have to transcend these good and bad moods. This is called Sattva-Guna. Otherwise, good and bad moods are called Raja-Guna and Tamo-Guna. So there is contextuality in the moods as well. So contextuality is not one thing, even though the term is often used very loosely. There are three specific kinds of contextuality which appear due to the three aspects called Sat, Chit and Anand. The method of dividing the whole into parts is called Anand. Then the actual types produced from this division are called Chit. Finally, these types are placed in different roles to each other, and that is called Sat. Factually, mathematics doesn't deal with any of these contextualities. So even though the general problem is contextuality, given that there are three types of contextuality, mathematics is incomplete due to each one of them. And because of hierarchy, each type of contextuality creates infinite variety through repeated combination. So mathematics is infinitely incomplete within each of the three types of contextuality.
If mathematics is so incomplete and the rest of science, like physics, relies on this mathematics, then the rest of science must also be incomplete. And if the incompleteness is infinite, then how is science working? Why is it so successful in building useful technologies? Doesn't it mean that science is working in some sense even without inducting this contextuality?
Well, working is a relative term. Science is working by studying the world in terms of few types, such as particle and wave. But there are many more types which are not being studied in science. Then science also tries to universalize these types, which means that it doesn't recognize that the world could be described in terms of different concepts, and each person is free to use a different set of concepts to describe the same world by adopting a different method of division. This idea is generally called Scientism, where only the current theories of science are considered the real theories. Alternative methods of describing the world by dividing the world in new ways are not recognized, or they are considered pseudoscience or unscientific. Finally, science also doesn't recognize that these types interact through roles, which means that not every object interacts with every other object. When you place these objects into roles, there is a relation between some objects through which these objects will interact. And each role brings a normative sense of behavior in which each object is supposed to behave in a particular way based on which we can formulate the laws of right and wrong behavior, accompanied by their consequences. So science is working by taking a very small subset of all that is possible. First, it takes only one method of dividing, disallowing other methods. Second, it adopts reductionism and discards the macroscopic types, such as tables and chairs, and recognizes only particles and waves. Third, these particles and waves are not situated in contextual relations to other objects, so there is no normative expectation about how a particle or wave must behave. Therefore, there can never be moral laws of nature in science. In all these ways, science is incomplete. But since science is taking some types, using one method, using a universal interaction model, it is still able to formulate some laws of nature, even though these are not the actual laws of nature. When we ignore the many possible methods by which each observer can divide the world, we lose touch with human subjectivity because each observer must divide the world in the way that science endorses. This ultimately means that observers have no choice in creating science, and that they cannot create a different kind of science. And the reality is that each person carries a personal theory of nature. When we ignore the many types we create by these methods, then we describe the world not in terms of everyday objects such as tables and chairs, but only in terms of subatomic particles, and this is another rejection of human experience which operates in the common sense world. By rejecting these types, science becomes incapable of explaining how the world works using everyday language which has innumerable concepts. How are we able to comprehend meaning and communicate that meaning with each other successfully and believe or trust each other when none of the concepts are real? By rejecting these types, we lose the understanding of mind, intelligence, and language processing. Finally, when we ignore the fact that objects are situated in roles, then we lose the idea of responsibility and accountability. Now we cannot speak about duties and the consequences of neglecting our duties. Our social, economic, and political realities are constructed based on these duties. If we remove this reality from science, then science cannot deal with the socio-economic, political world. In short, the social, cultural, historical reality becomes detached from the reality in science. So to say that science is not working is an understatement. Modern science rejects choice, responsibility, and meaning. We become mindless entities who don't comprehend meaning in terms of many types. We become deterministic robots who have no choice, and we lose the sense of responsibility about our actions, entailing the collapse of all moral laws and therefore of society. However, we can still build technology where these things are not important issues. For example, machines don't have choices, they don't comprehend meaning, and they are not responsible for their actions. If we take this model of scientific description to be the ultimate reality, then human society will collapse, because without choice, meaning, and responsibility, there cannot be a human existence, or at least the existence will be degraded. This degradation is a side effect of the ideology in science, and we can see people rejecting choices and responsibility and become duller by the day as they rely more and more on machines to do their jobs for them, and believing that they have no choice in doing so.
Most people will accept the negative impact of technology on human life. But people also argue that we are able to build powerful technologies that solve many problems. Their claim is that if these technologies are useful, there must be truth in science.
Yes, there is some truth in science, just like a book can be studied by describing its size and weight instead of its meaning. By measuring the size and weight of a book, you can gather some knowledge of the book. For example, a small book must be simple and a large book must be complex. This is an approximate idea because small books could also hold very complex ideas and big books might be about simple ideas. So, trying to reduce meaning to the size and weight of the book is not very accurate. Nevertheless, in general, small books will be simple and big books will be complex. The real study of the book involves studying the complexity rather than the size. But even to the extent that size imperfectly indicates complexity, we can say that by studying size, we are actually studying complexity. That's an approximation. Technology also works because we are able to give the material world a meaning, although it is not necessarily the meaning in matter. These are meanings that reside in our minds. For example, all computers are built using ones and zeros, but we don't suppose that atomic physics is dealing with ones and zeros. The ones and zeros are our interpretation of the physical world, and we are already giving meaning to a physical property, such as spin in this case. But even as we perform these interpretations, we don't acknowledge that the human mind is different from the material objects that we are able to manipulate using ideas in the mind. We are not saying that science doesn't have any success. I'm saying that scientific method is successful in a limited sense, and that there are infinite number of problems that we cannot solve by this method. As time elapses, we will find that technological progress will come to a halt, because all those problems which can be solved using the current method would have been solved, and solutions to other problems will lie beyond this method, which technology will not be able to provide in current science. The first wave of industrialization treated the world as height and weight. The second wave of industrialization uses digital computers, where physics becomes information. But the meaning of this information lies in the human mind, while the machine just churns information quickly. The third wave is just beginning now as AI and neural networks. It is trying to automate the mind and thinking without recognizing choice in the thinking or the responsibility that follows from that choice. In all these ways, nature is much smarter, but we dumb it down in science and technology. A smart system can behave in a dumb way, but a dumb system cannot behave in a smart way. We are dealing with a very smart system that involves meanings, choices, and moralities, but we are modeling it as a machine that is incapable of meanings, choices, and responsibilities. And we are using that machine to perform some jobs without these human qualities. As we enhance the speed and complexities of these jobs, we think we have improved science. But when we compare this advancement to everything that is possible, the current state of science is really dumb. If technology progresses by pretending that nature is a complex but unintelligent, deterministic, and amoral machine, then even with the progress, our lives will become instrumental, meaningless, amoral, and unhappy, despite the progress in science. We will equate meaning and happiness to the acquisition of instruments. So progress in technology doesn't mean human progress, it just means material progress.
Are you saying that the incompleteness of science is an important problem because it is connected to the question of our happiness and meaningfulness in life?
Yes, ultimately every human endeavor has to create happiness. Bodily survival and longevity are a small subset of the problem of happiness. Yes, we need a body, but alongside the body are many other tiers of reality. In Sankhya philosophy, there are 7 distinct levels of reality, of which the material world that science presently studies incompletely is the 7th level. The other 6 include qualities or qualia, the senses, mind, intelligence, ego, and morality. At the very best, we are restricting our happiness to 1/7 of the possible happiness. At the worst, the happiness of deeper realities is much more important than the happiness of the body. And by neglecting the deeper and more important forms of happiness, we are ignoring the real type of happiness and favoring the happiness that brings or that comes from the material body, which is very limited. The questions of incompleteness can be viewed in this broader context. Or what is it to be gained by understanding deeper realities than just asking why science is incomplete without inducting these deeper forms of reality? So the problem of incompleteness can be described essentially as 2 things. First, there are many deeper forms of reality, of which the material world we observe is only one. Second, each of these tiers of reality, deeper or not, has contextuality which science is unable to induct. The gross material world can be approximated by non-contextual forms of knowledge. But it is an approximation, and that approximation has greater and greater limitations as we step into the deeper forms of reality. Therefore, science becomes limited in studying the deeper reality, and when something is hard to define, you tend to say it doesn't exist. So incompleteness is also indirectly connected to the materialism of the modern world. Just because we are unable to study the deeper levels of reality, we are inclined to claim that this reality doesn't exist. As we fail to study these deeper forms of reality, we also fail to advance cognitively, because we cannot cognize the world without the right concepts. Those things we cannot cognize appear to us as noise, confusion, randomness, and uncertainty. The things we cannot understand are ignored because our consciousness defocuses from those problems, and that makes their solution even harder.
Maybe you can give some more examples of this incompleteness within science. You mentioned mathematics and the broader effects of its problems. But it would be interesting to understand how this basic linguistic limitation creates other kinds of problems in science.
Take, for example, atomic theory, which suffers from all the three types of contextual limitations. The first limitation is that we have to choose a method of dividing the whole into parts, which will produce a vocabulary, and atomic theory is not able to predict this vocabulary. This problem appears in atomic theory in our ability to use different eigenfunction bases, which are like different vocabularies created to express the same meaning. The second limitation is that since quantum particles are entangled with other particles, changes to one particle's state will change the state of the other particles too. This is the counterpart of the fact that if some cyan becomes red, then the magenta and yellow will also become blue and green. While entanglement cannot be described theoretically, which particles are actually entangled is not known a priori. Therefore, we cannot predict how changes to one system will affect the other systems. The third limitation is that when these parts are being detected by measurement, the exact detector that will detect a part is not predictable. A particular quantum can arrive at any detector, and which detector will fire cannot be said. This problem is the counterpart of the fact that it is one thing to predict what a speaker will say and when, and quite another to predict which audience will hear it. Similarly, in the case of relativity theory, there is a different kind of incompleteness in which we can predict all the events, but which actor will participate in which events cannot be known by the theory. We earlier spoke about this incompleteness and how it follows from the lack of meaning in judgments. In the case of computing theory, there is an incompleteness problem due to which the programs that will halt cannot be distinguished from the programs that will never halt. The inability to tell which program is halt is the inability to know the true meaning and intention of the program. This is a problem that we face almost daily in working with computers, because these computers can have malware, and the computer itself cannot know which of the software installed in it is useful or which one is malware, because we cannot tell the real purpose and intention of a computer program. In each such case, we are talking about an empirical fact that will occur, but which cannot be predicted by a theory. The root cause of this predictive incompleteness is that we are ignoring deeper forms of reality. To explain these unexplained facts, we have to add deeper realities to the theory, which becomes a problem in science if we are a priori committed to materialism and reductionism. So the problem of incompleteness is that we are unable to predict all the facts because we don't take into account all the realities. To solve this problem, we have to go back into the nature of reality and think about it in a new way.
What do you think is the role of Vedic philosophy in overcoming this incompleteness?
As we already said, to overcome predictive incompleteness, we have to induct new kinds of realities and update the understanding of the current reality. The updates include the idea of contextuality, and the additional realities include the different forms of contextuality. We have broadly spoken about three kinds of contextuality which act in different ways in nature. Vedic philosophy provides an overview of these realities and their behaviors and integrates them into a single coherent understanding of nature. So this is the key value of Vedic philosophy, which is that it can help us solve unsolved problems in science by telling us why science is incomplete, because nature deals in duality, the three modes of nature, and the complementary methods of dividing the whole into parts. Of course, one needs humility to accept the problems in science and their solutions. First, that scientific theories are forever incomplete, and that this incompleteness should be solved rather than circumvented. Most scientists don't accept this problem because the solution to the problem requires discarding many fundamental postulates of modern science. Second, that the revision of science is coming from ideas taken from Vedic philosophy, which is often equated to a religion. Given the historical conflicts between religion and science and the dominant atheistic outlook of modern science, scientists are averse to learning from avowed enemies. The key problem hindering the adoption of these ideas is the lack of humility regarding the failures of science and the lack of acknowledgement that someone else already did better in the past. And there is a fuller body of knowledge which is being incompletely and imperfectly understood at present. Third, that this knowledge is coming from an alien culture as far as the West is concerned. So accepting that another culture has superior knowledge needs humility. Due to unfamiliarity with the culture and due to the universalization of the Western culture and philosophy, it is harder to understand something that's alien to it. As we know, the lack of humility doesn't have a scientific or a rational answer. The very prestige of science is at risk if it acknowledges its own failings and or accepts that religion has a better answer to their problems. And there are issues of cultural superiority between West and East, due to which people refuse to look at alternatives. And even if they try to give up quickly, and even if they do, they try to give it up quickly because it's alien to them. Given these challenges, which are social, cultural, and political, I don't see how the current system can reform itself very easily. It is likely that modern science will continue to battle these ideas, and even if it were to accept them, they would have to be digested in such a way that they don't undermine science's prestige. Even if the ideas are coming from Vedic philosophy, it has to appear that science did it on its own.
This seems depressing. What do you think is the answer to the problems of scientism, where a wholesale rejection of everything else is taken for granted?
I don't think there is a single answer to the problem. We can try to keep the prestige of science intact by publishing in scientific journals, while carefully hiding the source of the intuitions, so that nobody in the scientific community feels threatened by the injection of new ideologies within science. We can also ignore the scientific community insofar as it is ignoring the alternative, and develop an alternative outside the mainstream, and wait for that alternative to win over time. We can also approach this problem by writing about scientific issues in a non-sectarian manner and sway the public opinion against the false dogmas, creating a greater acceptance for new ideas. The newer generation that grows up in a society with a broader set of ideas is likely to remain more open to the alternatives than those who have grown up listening and talking only about the current dogmas. At the very least, I view this as a multi-generational problem, not a problem of a single new theory, but one that involves a paradigm shift in thinking, along with the rejection of the current ideologies. That kind of transition is going to be slow in the beginning, but as with all such transitions, there is always a tipping point where we can observe rapid growth and popularity of the new ideas. This popularity may even be accompanied by rigorous logical and mathematical demonstrations of the ideas. But I don't see any easy answer to the sociological, cultural, and political problems associated with the prestige and pride of modern science. That's why I tend to ignore it at the present and focus only on the technical and ideological problems. Whether we can solve the issues of sociological culture and politics in science, only time can tell.
But are you hopeful that this problem will be solved despite the sociological hurdles?
Of course, I am hopeful. At least I am confident that we can present the ideological and technical component of the philosophy in an objective, non sectarian, rational, and empirical way. And this is the first important area we need to focus upon. We can talk about the sociological issues when we have a convincing alternative which is on par, if not more successful than modern science. Most people are not going to switch sides with known problems on one side and unknown solutions on the other. The ideal human response is that once you know for sure that there is a problem that cannot be solved in the current framework, you ought to switch immediately to something else, at least in the hope that this could be a possible solution. But most people do not take this approach. They think that we can circumvent the problems by newer techniques, even if we cannot solve them completely. They spend the time on mending the broken thing rather than looking for a new thing. Ultimately, this has to do with the risk appetite of the individuals. Most people desire safety and they are averse to big risks. So the initial phases of this effort will be marked by only those people who are prepared for big risks. It is only when such people are successful and they have proven that the rewards are big that other people will follow. This is, of course, a characteristic of the initial adventurers, and it is seen across all human endeavors where a few bold people set out to sail the uncharted waters and others follow them. The journey requires not just intellectual prowess to reset the old ideas, but also intense courage to follow through with your convictions on a somewhat lonely journey. Effectively, you need very brave ideologues.
Ashish, thank you for a great discussion today, and see you next time.